Hey everyone, in this video we're going to be talking about the two-stroke cycle. This video is part of a short video series on IC engines. So we've already talked about in the previous video on four-stroke cycles, and in this video we're going to talk about two-stroke cycles. So as you can see in the image below, you have a description of the two-stroke cycle, but it's not very complete, and we're going to go over it in some detail. So what a two-stroke cycle does is it allows us to use one revolution from the engine to complete a cycle. So as opposed to a four-stroke cycle where you actually have two different revolutions to complete a cycle, the cycle here is completed in one revolution. And since it is a cycle, you can start anywhere you want. We are going to start on the left of our diagram and kind of describe what is happening throughout the system. So in this first image, we actually see the piston moving upwards towards top dead center. So remember, top dead center is here, bottom dead center is somewhere here. And as the piston is moving closer and closer to top dead center, we have compression inside our chamber. So the gases inside of our chamber are being tumbled around and are being compressed more and more. We also notice that the piston usually has this kind of lip here, which we'll talk about in a second once we get a little bit further, once we talk about scavenging. But essentially what is happening in this part is, since it is a two-stroke cycle, two things are happening at the same time. We are compressing the gases in the top half of the piston, but also we are bringing in air through a reed valve. And a reed valve is essentially a one-way valve, a valve that cannot let air out. And the air is brought in by the fact that the pressure outside could be atmospheric, so you could have atmospheric pressure on the outside, and on the inside of our piston and on the inside of our engine case, essentially, so this part right here, right in here, what is happening is the pressure is actually lower than atmospheric. So we have a pressure that is actually lower than atmospheric because of the fact that the piston is moving up and therefore making more space for the air to come in. So we have air coming from the outside to the inside of the case and filling up the bottom side of the engine. Now, by filling up the bottom side of the engine, what we're going to be able to do is, through a clever bypass of the fluids, we're going to be able to get some air in much faster than in a four-stroke cycle. So initially, the piston moves up. Once the piston reaches top dead center, what happens is we go into the second phase of our diagram, where we have either a spark plug or a fuel injector, and usually close to top dead center. So when we reach this top dead center line, we're going to ignite the fuel and air mixture, and that fuel and air mixture is going to be exploded, and the piston is going to keep moving in this, the crankshaft and crank is going to keep moving in this direction, and the piston is going to start moving down towards bottom dead center at this point. It's going to move down under the power of the gasoline and air mixing together and burning, essentially. As this goes down, we start having some exhaust escaping through this opening right here, which is essentially a opening on the side of the engine. So different than in a four-stroke cycle, where you usually have valves and the valves open and close. Here, the piston moving down essentially opens the exhaust. So the exhaust, this goes out to atmosphere, and the exhaust opens usually a third of the way down to bottom dead center. The exhaust usually opens. We also see that the air that is in the bottom part of the engine, so all the air that has been induced right here, is essentially being pushed up this area right here and is actually being compressed. So our pressure at this point, our pressure inside the bottom of our engine is actually increasing, and it's increasing because we have this piston pushing down on this air. So we're compressing the air, and what we're doing is we're allowing for the air, once the piston moves down a little bit more, we're going to allow for the air to bypass and come into here. As exhaust is continuing to happen, we also have air coming into here at the same time. Okay, and that means that the intake and exhaust are open at the same time. And what we need to try and prevent is we need to try to prevent the air coming in through this side here. We need to prevent it from going out directly out to the exhaust. That would be very useless. We actually have to try and get all of the old exhaust air out and new air in. So what we do is we actually design, so if I erase most of my annotations here, we actually design our system to have this lip here so that essentially the air will be pushed up as shown in the diagram. The air will be pushed up into here and chase the rest of the exhaust out. So we're purposefully putting this lip there so that we can essentially make sure that we have intake air stay in the intake and not just go straight out the exhaust. So we're completing the exhaust and the intake at the same time. Now, once this process is done, we start going back up. So our piston starts going back up and the cycle is repeated. So a couple of things that I want to talk about on this side of things and talk about in general about two strokes is that some of the things that are very interesting about a two-stroke engine is since it has one rev to complete a cycle, that means that, for example, if at 5,000 RPM in a two-stroke engine, you would actually get 2 fires per 1 fire of a 4-stroke. And that's very interesting because that means we can actually get not double the power necessarily, but we get a much higher power to weight ratio and power to size ratio for our engine. We can also say that our engine is much simpler mechanically than a 4-stroke. And that is due to the fact that we have usually no valves. We also don't need, we need oil to help us lubricate things, but we actually don't need oil in this case. It is simpler mechanically because it has no valves. And so it comes out to being a much more simple and practical solution to have. Now, obviously, there are downsides to this. And the downsides is usually the longevity of the engine and the scavenging, which we'll talk about in a second. So one more thing that is positive for now is also we get a higher power to weight ratio. So typically the engine is a lot lighter and makes a lot more power because of this 2 fires per 1 fire for a 4-stroke. So we have a much higher power to weight ratio. Now, the big issue that we have to deal with is called scavenging. And scavenging is essentially the notion that whenever the intake and exhaust are open, we have to avoid the air from just going straight out of the exhaust port. We need to replace the intake and exhaust air. And that is a very, very difficult thing to do. Okay, so we can write that scavenging is a limitation to performance. And it is a limitation to performance because we actually have a real problem here. We need to be able to, if I draw the system again, we have our intake air coming like this, we have our exhaust air going like this, and let's say we have our piston cylinder assembly like this. So the intake air is coming through this tube, the exhaust air is going through this tube, and we have our piston drawn right here. The big issue is we have to design a system with a piston that will actually let the air move up and not straight out. And this is the biggest challenge for engineers who are designing this type of engine. Scavenging can be defined as just getting air out and in at the same time. And so what we want is we want our scavenging to be as good as possible. In a 4-stroke engine, we have time to get rid of most of the exhaust and put in some new intake in 2 separate strokes. So two separate movements of the piston from bottom dead center to top dead center, and then top dead center to bottom dead center. In our two-stroke engine, we have to do everything all at once while the piston is going from top dead center to bottom dead center. So it's a much harder way of doing it. And so from an engineering point of view, this has been very difficult to do. That's why four-stroke engines are much cleaner and much more efficient, not necessarily more powerful, but they're more efficient. In terms of the actual system and the actual research that has been done, most of the research nowadays is done on four-stroke engines, but two-stroke engines still have their place in very, very small engines as well as very, very big engines in boats, for example. And there have been some pushes to create better two-stroke engines in the future. And we are getting to somewhere where scavenging isn't much of a problem anymore. But there are other issues with lubrication and durability of engines as well. So that concludes this video. If you like this video, please consider subscribing. In the next video, we'll be talking about operating characteristics on work, torque, and power, and general engine geometry. So we'll see you in the next video.